The final way to take care of this issue of these binary decisions as far as statistical significance is to do something called create a confidence interval. For those in version 9, that's around page 300. For those in version 8, looks like it's around 374. The idea of a confidence interval is that you don't say yes or no to significance, but what you try to do is you try to construct a range where you say, if you're in the Taussman asthma program, here's how much you'll be helped. It's our best guess. You don't say yay or nay, but you say kind of how confident you are and how much you think it improves. So if you actually look at the table that I've put there for you, it actually gives a confidence interval. I'm going to explain a little bit about what this is. So let's go back to the data of the asthma program if we can. Before the asthma program, we had scores of 1, 4, and 7. After 2, 6, and 10. If I wanted to get a point estimate, one number, if you wanted to guess one number as far as if you were going to enter the Taussman asthma program, and I wanted to say, well, basically my program should help you by this much, what would be that number? What would be the point estimate for how much my asthma program would help? Well, if you use the data in this problem, the 1, 4, 7, 2, 6, 10, I would imagine that you would say, well, you know what? On average, I think the treatment effect is what you would use. I think my program will help you out by 2 points. So your point estimate would actually be a number of 2. So the point estimate would be a number of 2. The point estimate is saying, yeah, I think the before and after you'll improve by 2 points. That's my best guess. So the thing about a point estimate is that you're very specific on how much my asthma program will help you, but you don't have a lot of confidence because it's just one number, right? It's just a point estimate. So you might say, well, my best guess for how much my asthma program will help, the point estimate, is the difference before and after, 2. So you have a high degree of precision with that, but not a lot of confidence with it. So that's your point estimate. And take a look at where it has the 95% confidence interval. You notice what it has for the lower and the upper? Notice that the lower range is 4 and the upper is 0. What's in the middle of that? Yes, 2. So your best guess for a point estimate is 2. So what a confidence interval does is it says, well, I'm going to give you a guess. And the 95% confidence interval, the real world statement, which is all I really need you to understand here. There's a way of statistically doing this, but the key is to be able to look at an output and understand it, is what you would say about this table, what you want to write, is you are 95% confident that the true effect of the Taussman asthma program is between 0 and 4 points. You are 95% confident that the true effect of the Taussman asthma program is between 0 and 4 points. So the more confident you are, the wider the range. In this case, you can say I'm 95% confident that the Taussman program will help you between 0 and 4 points. So a confidence interval is a way of getting around significant or non-significant. It's saying I am 95% confident that the asthma program will help out between 0 and 4 points. And a lot of people use this. I know a friend of mine recently had a baby girl. They look at growth charts. They say, well, we're 95% certain that by the age of 5, your child will be between this height and that height. So when you do confidence intervals, you don't do statistical significance. You try to create a range of looking at these effects. So in summary here, we've covered a lot of these different things. Let me make some final summary comments that are also in the 2 chapters we've looked at here. One of them has to do with treatment effect. When we run studies, we hope we have a large treatment effect that tends to cut down on errors. We want a large sample size, but not 10,000 people, because that creates type 1 errors. And we hope the other thing that we often do is, I told you about that 0.05 two-tailed that we usually use. The reason we usually use that, it's called our alpha value, is because when you choose 0.05 two-tailed, you kind of minimize these type 1 and type 2 errors. So that's why we usually pick that. Thank you very much. Bye now.